Yo, mama.
Your mama.
Look, I just got both of them. Both.
Can somebody open? There's a fish question that I want to talk about, and there's okay. I want to hit the fish question. I want to hit this question. I want to do this one first, and then we'll get to the fish question, and then yes. A charger?
But not a laptop charger.
Just don't touch that part. Okay, so this question, does anybody, can somebody pull up their 13? Because I use these numbers.
I got you.
I used these numbers last period, and I want a different example for the video aspect of things.
I got mine right. I got mine right.
You got yours right?
Yeah, no, we got the same one. Hey, this way, you use mine. I wouldn't mind. That's right here. This page right here, homie. Yeah, it is. What are your numbers? I got it. All right, 13. What are your numbers? 13? Yeah. Oh, I got 13 right. What? Oh, yeah.
I keep getting a decimal for both.
40 and 24.
For this one?
No, for both questions. No.
Okay. Well, we can. I'll look at yours, Chandler, and see if there's a simple thing that you're missing.
Dude, their question bank is so small. Can you use my numbers? Hey, I got it right.
Sure, give me your numbers.
That would also my
Okay, 59. 59. Ready? 59. Okay. 80 feet per second.
That's the one I had.
Oh, I got you.
And a 96 and 192?
No. 64 and 128.
Okay, we can do that. So 80.
Chandler, what are your numbers? 40, 24. That's what mine were. I already have it right. Yeah.
So you said 80. This was 64.
Yeah. Whoa.
What was this one?
128.
128. Okay. So this asks us to use this formula here, which says H is equal to negative 16t squared plus initial velocity times t. Okay? So setting that up, we should have H is equal to negative 16 t squared plus 80 t. Okay? Now, so if you watch the video from first period at any time, it's going to be the same 80, but the rest of the values are different, so it doesn't turn into a different question. Now, I'm going to write it as h of t. Now, I know that they're not talking about functions yet here, but I like that notation, and I think it's appropriate because the parabola that we get, any parabola is always a function. It always passes the vertical line test. And what this, if I read this, it tells me the height at time t is negative 16t squared plus 80t. Okay? So if I can understand kind of the verbiage of what this algebraic equation says, it can maybe help me work through what I'm supposed to do in this question. Okay? First thing says, when does the ball initially reach a height of 64? So when, we'd be looking for t, right? A time. This is a height at a specific time. Well, they want the height of 64 at some specific time. So that's what we're looking at. Okay? Now, you can, and I'm going to do this a couple different ways, but if I was to use just my calculator, I can graph that, and I can graph that, and the solutions are going to be where those two things cross, correct? Okay? Now we've got a couple options. Let's use, I think last class I used GeoGebra. Let's use Desmos. I'll show you how you can use your TIA 384 as well. But all this is saying, guys, if I graph y equals negative 16, now I got to use x instead of t, 16x squared plus 80x, I get that graph. Okay, now I'm going to mess with the x and y axes a little bit here. Because I'm looking for when I go to, like, what did it say, 90, what did it say, 64, right? So I need to go up a little bit. If I even zoom out, it's going up to 100. So let's set the y-axis to go from, like, negative 10 to 120. So let's go by steps of 10. I don't like that. 20. And we get that curve. Is that all right? Okay. Let's make it look a little bit better by taking the x. I don't need the negative portion of the x-axis, so I'm just going to go like negative 2. And I don't need anything past like 5, so I'm going to just say 7. And I'm just using those values to give myself a little bit of room on the left side of the axis, bottom of the axis, that kind of thing. But that gives me a good image of my graph, right? Okay. They want to know when it reaches a height of 64. So this is, this here, this, what we're calling our x-axis down here, this is really our time axis, and this is our height at a specific time. Does that make sense? So we're throwing this ball straight up, and it's coming straight down. And if I take the times and the height of that ball when it's doing that, and I plot them in a two-dimensional plane like this, I'm going to get that red curve. Okay? Now I asked, when does it reach a height of 64? Okay, so that's the line y equals 64, right? We're interested on when those two things cross. That's the algebra that's taking place here. If I just click on them, okay, it will, you kind of see the gray dots show up there a little bit. See how it gives me 1, 64? So what that is, that's a time, comma, a height. So at time of 1 second, I'm at a height of 64 feet. Okay? Now, as it continues to go, it's on its way up, so it's going to reach a maximum, and then it'll start descending again, and at a time of 4 seconds, it gets back down to 64 feet. Does that make sense? Okay? So we should be looking for, when we do this work, we should get those answers, 1 and 4. Let's go through and do this work. And that's the thing, guys. The graph is great. It's awesome. But on a test or quiz, if you just give me the answer and say, I used GeoGebra, I used Desmos, I used TIA3, that's not work. Okay? So that's not going to give you credit. So if you got the answer, I give you a point. But if you got the work, I give you 10 points. Okay? So we need that work. You need to demonstrate the algebra here. So I'm going to move that 64 to both sides. Or remove it from both sides. So then it gives me this. Okay, now what I need you to understand graphically, this is no longer the same graph as this. Does that make sense to everybody? Okay, if I were to graph that bottom one, we'd be looking at negative, so y equals negative 16 x squared plus 80x minus 64, we get that curve, okay? And what we'd be looking at that curve intersecting is now that line right there. Does that make sense? However, Okay, so let's change this. Can you guys see that this is highlighting the x-axis? I can't really tell, but if I put the line x equals 2, or sorry, x equals 1 was the answer. Do you see how this curve here and that curve there intersect still at 1? And this curve up here and that curve right there still intersect at 1? Does that make sense, everybody? So no matter what I do to these equations, as long as I do it to both sides, I'm going to transform the graph. But the intersections are still going to exist. The left-hand and the right-hand side, where they intersect, is still going to exist somewhere on that vertical line, x equals 1. Is that okay? Okay. So, we subtracted 64 from both sides. If I would have subtracted 32 from both sides, I would still get the graphs to intersect on that line, x equals 1. Okay. So when I solve this, I look at that, and there's a GCF of negative 16, right? So I'm going to divide every single thing by negative 16. So it gives me t squared. This will be minus 5 plus then 4, right? And that should have a t with it. Does that factor? Yeah, that goes to t minus 4, t minus 1, right? T equal 4, t equal 1.
Yeah.
Which one is the initial one?
1.
The 1. It's the time, right? T stands for time. Initial meaning first. Okay? So the first time that we get to 64, a height of 64 is at 1 second. The second time we get to 64 is at a time of 4 seconds. Does that make sense? Okay. Now, the next part says, when do we reach a height of 128? Well, let's look at the graphs again. If I want to get to 128, I'm going to change this to 128. And what do you see graphically about those two curves? It's impossible. Okay? That line right there and this curve do not cross, so it's impossible. No solution. All right? However, if you just write that and don't have supporting work, I can't give you credit. So what we'll do is we'll take 128 is equal to negative 16 t squared plus 80t, and we'll work through to see if we can generate a solution or a result that indicates it's impossible for that to happen. So again, I'll factor. I believe there's still a 16 of 128, right?
Yeah.
Okay. So this gives me, so I'll divide everything by negative 16, so it gives me t squared minus 5t. Okay, then what, plus 8? Okay. Two numbers are multiplied together give me 8, but I have to give me negative 5. There are none. So then I turn to this thing. Which, that gives me 5 plus or minus. 25 minus 32, negative 7. All over 2, right? That number right there is referred to as the what?
Starts with D.
Starts with a D.
Discriminant.
Discriminant.
There we go.
Okay. So that is the discriminant. And when the discriminant is less than 0, you have no real solutions. And that would then be the math that I need to see. I need you to produce that negative discriminant, okay, to indicate that you know it's impossible. Is that all right?
Yeah.
And that's the thing, guys, with when we start taking paper and pencil tests, we want to demonstrate, even though we might use our calculator to confirm things, Whenever I take a test, I use my calculator initially to find the answer. And then obviously I know I got to show the work, so then I try to determine the work that's going to support that answer. Does that make sense? Okay. You can do that. That's basically what we did just when we saw that problem by itself. Okay. We went to the graph first, looked at those things, and then say, okay, how can I mimic that work? Okay, or those solutions through work. All right, now the next three, I don't like these questions. I don't like the order of them. I prefer to do E first. So when does the ball hit the ground? Because we're in the mode of plugging in. We plugged in 64 for H. We plugged in 128 for H. When it hits the ground, what is H? Yep. So that's all this phrase is. It's a different way of saying when does the ball reach a height of 0. So then what we'd be doing is we take our H of t and let that be 0, and then negative 16t squared plus 80t, right? Okay. Now this one's nice because there is no c term, so this will factor this way. So then I get negative 16t is equal to 0. T minus 5 is equal to 0. So this one's going to give me a time of 0, and this one's going to give me a time of 5, right? Does that make sense? Okay. Now you could graph this. I just don't want to go to Desmos or anything. I want to kind of walk through this concept with you with this picture. What we're saying right now, because the A term is negative, is that concave up or concave down? Concave down. Okay. Right now what we just found is that at time 0, we're at the x-axis, and at time 5, we're back to the x-axis. So our parabola is doing something like this. If it's concave down, it's got to reach a maximum somewhere, and then it's got to start falling and go back through 5, right? Now this is the reason I'm drawing this picture, because the next question, part D, says when does the ball reach the highest point of its path? This point right here, you call that the what? That is the vertex. And the vertex is always, 100% of the time, in a parabola, it is on that line right there. What do we call that line? That is your axis of symmetry. Okay? And the axis of symmetry, the idea of symmetry is that it's the halfway point, right? Sure. So that's the line that exists halfway between your x-intercepts. Your vertex is always going to be halfway between your x-intercepts. So where does this line exist? At what time? 2.5. So that's what we're looking at right here, 2.5. When does the ball reach? When, remember, is a time, right? Okay, when does it reach its highest point? Okay. The next question says, what is its highest point? So part C, what is the greatest height reached by the ball? Do you kind of see how maybe these questions are backwards?
Yeah, I don't like it.
Okay. And that's the idea, guys, is that when we approach problems like this that are staggered, my thought is not to try to approach question 1 first, question A first, question B second, question C. Holistically answer the question, get your solutions, get your graph, get your ideas kind of organized, and then from that go back to, okay, what's the answer A, B, C, D, E from that information, okay? Because a lot of times the way they structure their questions might not be kind of a linear progression like you want it to be, okay? So we get 2.5. Now we got to figure out the height. So we got to figure out H, okay? And this is the reason I like to write it as H of t. We know H of t, the height, is found by this formula, okay? Well, do we have a current time that we know we're going to reach our maximum height? So can I say H of 2.5? And what this says is that the height evaluated at 2.5 is equal to negative 16 times 2.5 squared plus 80 times 2.5. Okay, so 2.5 squared times negative 16 should give me negative 100. 80 times 2.5 gives me positive 200. Add those together, I get 100, right? All right, so when I read this, this says the height at 2.5 seconds. That's what this says right here. The height at 2.5 seconds. Equal sign is the word is, right? 100 feet. So that then is the solution to part C, 100 feet for us. Okay? Now, that's a graphical approach. My hope is that you guys remember a little bit from last year. And there's algebra that says that the vertex, and we'll see this again this year, and we use this a lot this year, the vertex of any parabola has an x-coordinate at the opposite of b divided by 2a. You guys ever remember seeing that? Okay. Now, obviously, we might have to, in this case, instead of x, we're using t. Okay. But what maybe generic formula you were provided with last year is that if we have an x comma y for a parabola, if it's the vertex is located at an x value that is determined by taking the opposite of b divided by 2a, and the y value is determined by taking and evaluating your function at whatever that x value was. Okay? So, for us, we had h of t is equal to negative 16t squared plus 80t, right? If I do the opposite of b over 2a, the opposite of b would be negative 80. 2a would be negative 32, right? If I divide that out, it gives me 2.5. Then the y value, which we're calling h of t, is found by taking that 2.5. I've already done this work, but I'll write it down again. And using that 2.5 as the time inside that function, it should give you 100 back. You guys remember doing a little bit of that? Okay, so you got two techniques, right? If at any time you think, well, my process, it's not click, it's not making a lot of sense to me. Maybe I'm questioning whether I'm doing it right. Can I do it the second way and see if I mimic the same answers? Yeah. And if I do, then maybe I can be rest assured that I am doing it right. If they are different, maybe then I want to think about the one that I'm more confident, the approach that I'm more confident in. Say, okay, that's the one that's probably giving me the right answer. How do I adjust the other one? How do I fix my issues with the other one? Okay. And throughout the year, I'm going to. That's the thing about college algebra that's maybe a little bit different than algebra 2. Algebra 2, you talked about this stuff, but now in college algebra, we're going to talk about multiple ways, and then kind of understanding the procedures and the process that we can go through to use those multiple ways to kind of validate solutions. Does that help on that question? Okay, now the reason I want to show that question, guys, is the final that Rhodes has written in the last 4 years has incorporated one of those. So I want to make sure that we have that resource somewhere. Okay. Fish problem. The fish problem, number 4 in the second assignment, right? All right, you're going to be frustrated with this. I'm frustrated with it because the second part, the answer that they're asking for doesn't make sense to me. Okay. So we'll do it and we'll talk about it. First part should be no issue. Okay. And the second part should be pretty logical, but I don't agree with their answer. I gotta zoom out. So what I'll do on this one is give you points for that second part, the October 1st answer that you're seeing on mine, because I don't agree with the October part of it, okay? But it says the fish population in a certain lake rises and falls according to the formula. F equals 8,000 times the quantity 28 plus 15t minus t squared, okay? So that's, like, biologists really do this type of stuff. They go through and they do catch and release tagging multiple times and recording data, and they can use that data then to generate a formula that demonstrates an expected population inside those environments. Does that make sense? Okay. So that formula isn't just hogwash, somebody made it up. There's logic behind creating that. So it says the population can be modeled by that, okay, and it says F is the number of fish at time t, where t is measured in years since January 1st, 2009, when the fish population was first estimated. It says, on what date will the fish population again be the same as it was on January 1st, 2009? Okay. So what we want to do here is take this thing and try to determine what the fish population was at time 0. Does that make sense? Okay. Because time 0 would be the initial time, correct? Okay. So if I say F is equal to 8,000, 28 plus 15t minus t squared, okay? At the initial time, and I just want to check the question real quick, make sure I haven't left anything out when I cut and pasted this, did I? Just want to, okay. So that is what we're doing. We're going to take and figure out what was the population at initial time. So at initial time, that's when t is equal to 0, right? So can I put 8,000? This would be 28. This would go to 0. And that would go to 0, right? So I'm looking for what 8,000 times 28 looks like. And it's that number there. Okay. So now the question is, when will we reach that population again? Well, that population is solved for F, right? That's 224,000 equal to 8,000 times the quantity 28 plus 15t minus t squared. If I solve that equation, thinking about what we just did to get that 224,000, one of our answers to that equation should be 0. Does that make sense? The other one should be, right, I think we're going to find out it's going to be an integer, which is nice. But now solving this, I'm going to take the equation, divide both sides by 8,000, which we just kind of already knew or did the math to tell us that that's going to be 28, right? And I've got 28 plus 15t minus t squared. Do those 28s cancel? Okay, so 28s cancel, leaves me 0 is equal to, I'm going to multiply everything by negative real quick, just so it turns into t squared plus, or sorry, t squared minus 15t. And now that factors. Has a GCF of t in it. Just be careful here, and people overlook this all the time. That's an answer. That's a factor. So we have to say t could be 0, and that's a solution. Okay, it's just, in terms of work, it's almost trivial because there's really no equation to work through, right? There's no work there. Where here, if I go t minus 15 equals 0, I've got to do a little extra work. So t is 15. So at time 0, which what they're saying was January 1st, 2009, our population is 224,000. 15 years later, it gets back to 224,000. Does that make sense? Okay. Now, says, what is then the date? Well, if 2009 was the initial time, 15 years later would be 2024, right? Okay. So take 2009 plus that 15, you get 2024. It would be January 1st that happens on. Okay? All right. Now the next question asks us, when will all the fish have died? So what would be the population of the fish if they've all died? Be 0, right? Okay. So if I have F was equal to 8,000 times 28 plus 15t minus t squared, and that was giving me the number of fish that I have at a particular time, and I want my number of fish to be 0 here, I should have that, right? And divide both sides by 8,000. At the same time, I'll multiply by a negative so I can reposition these. So I get that. Now that thing does not factor. So I got to use the quadratic formula. So I'll have 15 plus or minus 225 minus 4 times A times C all over 2A. Okay? That gives me 15 plus or minus, is that 337? So 56, what's that, 112? Yeah, it should be 337. 28 to negative. Excuse me, 337 underneath, and then 2 here. Okay? So it gives me 2 times. 15 plus root 337 over 2, and 15 minus root 337 over 2. Now think about this. This makes sense. This should make sense. 337, that's bigger than 225, right? If 337 was 225, that second answer would be 15 minus 15. It would be 0, right? So now if I go 15 minus radical 337, shouldn't that numerator be negative? Does that make sense? Okay. So that negative answer doesn't work. And now let's talk about why it's negative. When we first started looking at this lake, and we created this formula from the information we got from the lake, we knew there were already fish in that lake when we started, right? January 1st, 2009, we knew there were already fish in the lake. Okay? So if we go backwards from 2009, which is that highlighted number is telling me that that'd be kind of the creation of the lake. Does that make sense? If I go 2009 and then I add on that yellow negative number, should tell me the creation point of the lake, or the estimation of the creation point of the lake, when there is absolutely no fish. So logically, hopefully that makes sense why that's a negative number and what it represents. Okay? This number, positive. But if I take that number, just do a little bit of, get Desmos open here real quick. Let's use this one. If I go 15 plus the square root of 337, divide that by 2, gives me 16 years, 0.67 of the 17th year, right? So I know I'm in the 16 years. Well, if I think about 2009, Okay, January 1st, 2009 is what I started with. Add 16 years to that. They get me to 2025. Is that answer there, right? Okay. Now, here's where I disagree with what they've got here. And hopefully you do too. This means, this number right here means that we are in, can I highlight it? Do it this way. That number there, stupid thing. That we're into like 2/3 of the 17th year, right? So what I'm going to do is I'm going to subtract 16 from that number. So I subtract 16, it just leaves me with a decimal portion, right? So I'm looking at 2/3 of just a year now. Well, if I go month-wise, what would I need to multiply 0.67 by to see what month we're existing in here? 12. So it gives me the 8th month, right? Okay. So that means I've gone through January, February, March, April, May, June, July. August is your 8th month, right? And the 0.14 is into the next month. Does that make sense? Which would be what month? September, right? Okay. Now, how many days are in September? 30? Okay, so if I subtract 8 from that number, okay, and then multiply that number by 30, my argument is that that should be September 4th instead of October 1st. I don't know where they're getting October 1st.
Wait, what's the 10th month?
Mine's 14.88152. I don't know.
14 years?
Yeah.
Okay, so then, yeah, subtract 14 from there. Multiply that by 12. Okay, so you are in the 10th month. Actually, no, you'd be in the 11th. You'd be in November.
That works for me also.
You count it right?
That's what I had first on my, and then I thought
So-
October, and then I put November.
So I think they've got something messed up with the month. Okay, so it might work for some of you, it might not work for some of you. Mine's showing October, and if we do the work, it puts us September 4th. And if I subtract 4 from there, I can actually find the hour. I can keep dwindling that down to essentially the minute that all those fish die. Okay, so yeah. Are there any others on here that you guys want to talk? So I'll go back and I'll just award everybody a 1 point for the assignment. I don't, and I can't see the algebra behind the scenes for that question that's generating their answer. But does what we did make sense? There aren't, I've been using WebAssign for 5 years, 6 years. There aren't too many questions like that where they've got, like Math Excel, I find a lot more errors in Math Excel than I find in WebAssign, okay? And WebAssign actively, like if I email them and say, hey, we've got issues somewhere, they will actually kind of engage in that discussion where Pearson, they just say, forget you, we're making money anyways. Are there any other questions on there you guys want to talk about? You want to do the boat one? Give me...
5 and 19.5.
I'm going to use Chandler's numbers.
What?
I'm going to use Chandler's numbers. What's up, Shane? All right, so boat's going south.
I remember I did this one.
Boat's going east. How fast is your boat going east, Chandler?
1 hour faster.
Then the south. So let's let this one be R. Let this one be R plus 1. What do they tell you that distance is? 35 miles, and that's after how many hours? After 7 hours. Okay. So let's do this. So this is a rate. That's a rate. And this is a distance, right? What is linking all these things together is that thing there, right? Okay, the Pythagorean theorem talks about distances. And so if you want to change all those things to distance, you can. But as long as those things are all rates or they're all distances, the Pythagorean theorem will work. Okay? So did you change everything to a distance or did you change everything to a rate?
Distance.
Okay, so if this is R, okay, I'm going to rewrite it as a distance.
Please pardon the interruption. We have some reminders about Wildcat Time today. We have an ASL club meeting today in Mrs. Beckman's room, 101, and we have a Spanish meeting in Mrs. Oliver's room, room 209, and we will have a softball meeting in the auditorium, and those are for anyone interested in a particular meeting. Thank you. Goodbye.
So remember that distance is found by taking a rate times time, right? So if I know my rate is R, and I've traveled for 7 hours, then I've traveled a distance of 7R. If I know my rate is R plus 1, I've traveled for 7 hours, I know my rate, my distance is 7R plus 7. So now plugging that stuff into Pythagorean theorem, we can get, so let's just say 7R squared plus then 7R plus 7 squared is equal to 35 squared. So give me 49R squared. Give me another 49R squared. 49 times 2, what's that, 98? 98R, followed up by then another 49, is equal to then 35 squared is 1225. Combine like terms, I get 98R squared plus 98R, and then I'll remove that 125 or 1225 from both sides. I get 1176. Hopefully all that's divisible by 98. It is. So we get R squared plus R minus 12 is equal to 0. And that'll factor to R minus 3, R plus 4. So R is equal to 3, or R is equal to negative 4. Rate can't be negative. So R would be 3. Does that make sense? Okay, now, we changed everything to distance. I think that makes sense for most people because the Pythagorean theorem is a theorem on distance. Okay? But if you wanted to, you could have just, if that's a rate, we know rate is equal to distance divided by time. So I could have taken that 35 and divided by 7 and got 5, and then just said R squared plus R plus 1 squared is equal to 5 squared. That would be R squared plus 2R plus 1 equals 25. If I go ahead and work through simplifying that, it will create that R squared plus R minus 12 almost instantly, which is a little bit easier than work with those larger numbers of 98 and 1 or 1225. That's remember that assignment's due this evening, midnight, 11:59 p.m.
That one is?
Yes, sir. Okay?
Both of them are. Yeah, that's one.
I have a question about 16.
Yeah.
It looks like the problem, the exact example problem we did, we went over in class, and the answers didn't line up, 2/5 and -3.
Let me, it'll just be quicker if I do the problem here, and then we'll see if my work matches up yours. So we got 1 over R plus the 6 over 1 minus R. 12 over R squared. Let me pause this